Aquaponic farming is an agricultural technique that grows fish and plants simultaneously within a single system. The objective of this type of farming is to utilize less resources, like land, water, nutrients. This is all to provide a healthy crop of fish and plants. The water in the fish pond is used to water the plants, and once it's filtered by their roots, the clean water is returned to the fish pond to be utilized by the fish again. My name is Cynthia Wirtz. I'm a mechanical engineering student, and my main focus is on the aeration systems of the team. So I don't really work so much with the electrical and software components, but I've worked a lot with the specific aeration design, doing fluid flow analysis to predict how our design is going to perform, and to narrow down, to go through that design process and narrow down different concepts our team came up with. I also became team lead for the project starting in the fall 22 semester. So fall 22 and spring 2023, I've been the team lead for the project. So on top of all of the design work I've done for the aeration system, I also work a lot on that higher level of working with contacting sponsors and other general management needs for the team.
I'm Avery Castle. I'm a fourth year environmental engineering student at Michigan Tech, and I started on this project 2 years ago now. Within our project, I am a team member, and I work on the physical aerator design aspect of the project. Our sponsor for our project is Tree Frog Aquagric, and their goal is to build aquaponic systems in developing countries to help fight food scarcity. Tree Frog is just kind of beginning some of their aquaponic ventures, so they were looking for some innovation into their current setup to try to maximize the efficiency and the effectiveness of their system.
They recently started using a new technology called Atlas IoT. Atlas IoT is a product created by Atlas Scientific, and it is a hub for a bunch of different aquaculture and aquaponics sensory devices. And so essentially you can plug in all of your different sensors into this one area and monitor your entire system using this one device. My name's Riley. I am a physics major. I started with the aquaponics team in the fall of 2021, and initially I was the team lead, so I helped lead us through the initial research process and figuring out kind of what we wanted our initial subsystems to focus on. I've been the person who's primarily been dealing with the IoT system, working with how we're actually going to involve the customer on site in the management of the feedback control device. We know that water is H2O, but there's also an additional amount of oxygen that's mixed into the water that fish need in order to live, and that plants produce, and is also introduced into the water through other methods, like mixing the water or the air diffusing into the water.
Our team chose aeration because oxygen affects a number of different parameters within the system as well, like ammonia and the nitrogen process. And I feel like we had a pretty good working knowledge of how oxygen can be manipulated within the system, or how it affects the rest of the system. So because of that confident background knowledge, that was a good place to start. So the aeration system itself is supposed to kick on when water is low in oxygen, and so it'll pull water out and spray it back into the pond, and that interaction between the water and the air will increase the oxygen in that water, and that'll be mixed within the pond, and the overall dissolved oxygen concentration in the pond will increase, and so that will just provide more oxygen for the fish and the plants, who both require oxygen to respire.
So because Tree Frog is in Kenya, it has been an interesting time communicating with them and getting information on what the site looks like. Typically, we talk with them through WhatsApp or email, and those are the major ways that we have gotten information about the site from them. It's definitely been a process talking with them and having meetings with them just because of some connection issues too. So there were a couple reasons that going to Kenya was really valuable. The first one was in testing our prototype 1 and actually getting an understanding of how it worked in the system, how it worked with their electrical grid. I mean, it was a really, really big deal for us because we had such limited communication with them prior to this. The other reason that going to Kenya was really valuable was establishing some more engineering empathy. Because we had not been to Kenya, because we were not really too familiar with the system or the communities, some of the dynamics. We didn't have a great idea of how to engineer and what to engineer, I guess, what to implement for some of our devices. And being able to actually go and see how the people think a little bit differently than we do, and some of the design constraints that we just had not heard about, it allowed us to get a better idea of how to build our second prototype.
After implementing the device during the summer, we were able to gain a lot of feedback about what worked really well with that first prototype and some flaws and design improvements that we could work on. The major design flaw and component problems that we had was that the flexible hosing that you get for a high pressure system when operating a pump, it was forcing our prototype down, and our flotation devices weren't able to overcome that force. One of the design considerations for our second prototype was to create hard-lined PVC that would just be mounted to the side of the fish pond and not it wasn't designed to move around. To combat the problem of trying to circulate water in multiple areas in the pond, is we decided to have a dual outlet system. So that way water was being drawn in from one source but then being spit back out into the pond in two separate areas. Our team didn't have the capability to successfully recreate an environment that has organisms that utilize oxygen. So what our team decided to do was to test in two different environments. We call it our small scale testing and our large scale testing. So our small scale testing is to look at, try as hard as we can to actually look at how the aerator mixes the water. And with that, we were able to look at air temperature and dissolved oxygen concentrations. We operated our aerator to look at the temperature changes and see our dissolved oxygen increase, which we were able to observe. Our team has been really gearing up to test our aeration device in these simulated environments, but next steps to be able to get this ready to go on site for our sponsors to install are to model exact dimensions of what exactly dimensions of PVC and how to install it, so to have an installation and operation guide, which are all things our team are working on right now. So those need to be completed for our sponsor to have it. Also to communicate with our sponsor like a shipment plan of how to get our materials over there and how to get their system set up. For the past 2 years, we've been focusing on this the nutrient management dissolved oxygen feedback system, but our sponsor has a lot of other needs that they've expressed from their system. So as that wraps up this semester, future teams can look at improving the system and adding on to the dissolved oxygen even more, or they can look at other objectives that Tree Frog is interested in themselves.